Alrighty, so hopefully you've learned some things on how to send a laser tag signal and how to receive a laser tag signal. Now we're going to combine the two into one glorious sketch. Let's see, what are we going to do? I know. Let's make a Sentry device where we could shoot it and it will remember the laser tag signal that we shot, and then it will just keep repeating that laser tag signal. So I went ahead and printed out the sketch here, and so I'm just going to go through it real quick. If you don't know what any of this stuff does, just rewatch some of the other videos here, but I'm just going to go through this real quickly. Up here we're going to define some variables, sensor pin, LED pin, and a pulse variable here. This is used to receive the laser tag signal. Then we're going to define the values for different for our laser tag information, and there's 7 bits in that. And here we're going to define each of those sections here. Then we're going to do something new. This is a Boolean. This is a flag here, because everything is based in the sketch whether if we have received a tag or not. If we received a tag, then we want it to continue to repeat that tag. If we haven't received it, then we just want to keep looking for a tag. So this is a flag here. A Boolean means it's either true or false, and so we're going to set this up as tagger received as false. Okay, and then send tag delay 1000. So this is the delay that we want once we receive a tag. Wait 1000 milliseconds, and which is effectively 1 second, and then we're going to repeat that tag. Wonderful. So here we define all our variables. One thing I might mention is that when we define all our variables out here before the setup or any functions, we're declaring that these variables are what's called global variables, meaning they're going to be used throughout the whole sketch. If I declare a variable here in this sketch, say byte name something, so anyways, I declare a variable here. This variable is only useful in this function here, setup. And if I go in the loop and I call this name, it won't know what it is. So that's why we declare variables outside here, up here, because these are universal variables. These are only within the scope of this function setup. So that's what that's there for. Just a little bit of bonus information. So here we're only doing 2 things. Pin mode, we're saying our sensor pin is going to be an input pin, and our LED pin is going to be an output pin. Pretty basic. We go to our loop now, and here's where the fun begins. So if tagger receives, so if this is true, meaning if this is equal to 1, if tagger received is true, because the Boolean can either be 0 or 1. If it's 1, then that means it's true. So if this is true, then we want to do these things within the brackets here. If not, we want to do else get tag. So we remember we're starting off as false. So this is not going to be true, which means we're just going to automatically go to this get tag function here. Okay, so let's go ahead and do that. Here's our get tag function, same as the last video. We zero out our pulse X here. Then we want to look for the first pulse. Then we look for the second one. Once we get both pulses, then we read the data. We put that into our pulse array here. And then we look at the last 2 digits to see if they're 0. If they are 0, that most likely that this is a tag. So then we want to go to a new function called parse tag, meaning we want to interpret the information that we got. And then we want to flip this flag saying tagger receive as true. So now when we come back up here to our main loop, now that it's true, we'll go ahead and start doing this part of the sketch, and we'll just avoid this. Great. So if we have a valid tag, we want to parse it. We want to glean the information from it. So that's what this is. Parse tag, and we declare a range. So if the pulse we get is within this range between about 2000, then we want to change this first variable to a 2. And we go all the way down the line here, which means if it's not within this range, it's going to keep it as a 1, because that's what it originally defaults as a 1. Beautiful. Great. So now we're done with that. After we're done parsing tag, we come back up here. And now tagger receive is going to be true. We want to send a tag. And as you remember in my first video, how to send a tag, we pulse IR 3 milliseconds, delay 6, pulse IR 3, delay 2, and then we send the data here. And this is effectively going to mirror the shot that we received. And this is how we pulse the IR. We send the number into it, in this case 2, or not this one. In this case, whatever PL is, it might be 1 or 2. And we declare it as a byte as millisecond. We use a tone and to activate the LED pin at 38,000 cycles a second. Delay this variable here, and then we shut off the tone, and that's it. That's how you send a laser tag signal. Just a quick recap. And that's all we need to do. Very, very simple sketch here. So let's go hook it up and see it in action. Okay, we're going to now build this, and I have this left over from the last time. So we have our receiver here. All we're going to do is hook up the infrared LED, and remember the longer lead goes to our positive voltage, which is coming from pin 5. Yes, pin 5, and then this goes to ground. So we'll just go into our like that. So now this is going into the negative rail. We got to attach this to pin 5, and I need a longer. I'm going to take this out, and I'm going to put this in 5 volts. Making sure that's at 5 volts. Yep, and then this goes to positive lead there, and then this goes to pin 5. Let's just verify here that everything looks good. 5 volts ground, pin 5 and pin 4, and everything looks pretty good. Pretty good. Okay, so we got our sketch here. So let's upload this. First I got to plug it in and upload. Here we go. We're in. All right. So the idea is we're going to shoot this on one team, and actually we're going to try shooting it. So we're going to shoot this just on solo, and I should be able to hit when it fires back. I should be able to shoot myself with this. So let's see here. Solo. Yep, there we go. All right. Every second. Okay, so I'm going to go back into the sketch here, and a couple of things I just realized. First off, I went to the effort to create this variable, but I didn't use the variable down here. So I'm going to go ahead and copy this variable and put it down here. And 1 second is very, very fast. So let's make this 5 seconds. That's a little bit more usable. So that way it's not going quite so fast. Okay, cool. So now we're going to plug this in, and let's go ahead and upload. Nice. So let's go to put this on team 1. So the idea, of course, is we're going to shoot this with team 1, let it store that tag, and anyone on team 2 coming by will get hit. So we'll shoot this. Okay.
Now, what might be good if I were to actually build this for the field is maybe put an LED on here or a counter or something to say, oh, if team 1 shoots it, turn on this LED, turn on a yellow LED, or team 2 shoots it, turn on a blue LED, or maybe show a number of what team owns it, or something to indicate that it's active. But this is just for demonstration purposes. Okay, so let's put this on team 2. So the Arduino is firing back that same stored shot every 5 seconds. Nice. So that's a very simple Sentry device that you could build for your laser tag games. Now you can, and it's up to you how if you want to modify this. Maybe you want to say, hey, but maybe someone on team 2 can shoot this and maybe overtake this, and then they can own it. Or maybe there could be like a numerical keypad here. They have to type in a code to unlock it, and then they got to go find the code somewhere in the field to unlock it. Or maybe you have to find a key, or there's so many different things you could do with this. But the basics of sending and receiving a laser tag signal is this, and it's very simple. Hopefully this is something that you understand now and how it works, and you can take this information to build something really cool for your laser tag adventures. So anyways, thanks for watching. Bye-bye.